Hello everyone and welcome back to my channel, Tech Design Teach, and we're going to continue on the second lesson of the CO2 Car Drawing and Design series. Now I started to draw the cartridge and finished that and the rear axle hole in my first lesson. Now, like I said in the previous video, it doesn't matter what kind of car you're drawing or designing at this stage. Everyone's car is going to start out looking like this, exactly with the same values I'm using from the hub, and later it's going to take kind of a different shape. Now, we're going to refer to the hub again. We're going to go back into CO2 Car Project Outline and scroll down, and we're going to look at car length again. So we've established in the previous video that the blank is drawn for you at 12 inches long, which is the maximum length that your CO2 car can be designed to. Now, the minimum is 8 inches, and we can be any number in between. And this is something that typically gets forgotten. Students will look at this and they see the 12 inches and they think, oh, I have to use the entire length. Well, you don't. And as I continue through this process, I'm going to shorten mine up today. If you want to leave yours at 12 inches, that's totally fine because that's an option you can do. But if you want to shorten it up, that's fine and encouraged. So the minimum is 8 inches, but I'm going to use 9 inches. I've decided. So to continue on, I'm going to hit offset. I'm going to type 9, enter. I'm going to offset from the back forward. I'm also going to do the same thing on the top view. So all of this geometry on the left side of this vertical line has to be either gripped and pulled back or trimmed or erased. So I'm going to start by erasing these lines because I don't need them anymore. And what I can do is I can use a grip and pull it back to this endpoint. I thought I'd use a grip today instead of using the trim command for a change. Whoops. Undo. Okay. So that's what I should have. Now, looking at this chart again, it doesn't give me a dimension for the position of the front axle hole. It does give me a height, which is 3/8. So the rear axle hole and the front axle hole have to be on the same height from the bottom of the car, but it doesn't tell you where the front one goes. So that means that is also something that you have to design as a part of this project. You're going to decide what position this front wheel is going to be located with that axle, right? We know that the rear is locked in stone, and the reason that I have that in a certain position for you is to avoid a problem with the cartridge hole and making sure that you're not going to drill into the cartridge hole and create issues for that. So that's kind of already been pre-worked out by me for you. The front axle is pretty free game. So I'm going to go back, and of course, these numbers I'm using today you're not going to find in the chart because that's part of design work. So I'm going to select 6 3/4 for my front axle position. So I have to type that in. Your numbers may be different, of course, and encourage. So I'm going to use this line from the back, offset forward, and again, I'm going to do the same thing for the top view. Whatever I do to the side view, I must do to the top to maintain orthographic alignment. Okay, so this line and this line are going to represent a center line because this represents the center axes of that axle hole. We know that we are using an axle hole of a 1/4 inch diameter, the same thing we did for the rear. So that's what I'm going to start with. I'm going to grab the circle center diameter, go to this intersection, key in 1/4, 1/4 inch. Okay. And another thing I can do, I didn't do this the other day, but I'll do this now. I should have done this already, is create another offset of 2 3/4 and bring this center line into this position to match the one we're seeing on the rear. So that is something I should have done already. We're going to make this into a center line. Okay. So next step is to show the hidden lines for the axle drilled holes. So there's a couple of ways that you can do this. I'm going to show you 2 different ways. You can grab the line command, zoom in, click onto the intersection of the axle hole, and you can click above and then snap that to the quadrant. You can also right click, repeat line, find the intersection, and come up to the perpendicular. If I said quadrant before, I apologize. These are perpendicular snaps. And then trim that away. This line and this line become hidden lines. Another way that you can do this is you can offset this center line 1/2 inch. So you remember, how do you find 1/2 a fraction? Well, your numerator stays the same and you multiply the denominator by 2 or you double it. So what we're going to do is that's going to give us 1/8. 1/8. Click to the left, click to the right. So same result, just a different way to do things. Hidden line. Okay, so far all of this is orthographically projecting properly. So we have axle holes at the front and the rear. Now these center lines, they are way too long, so we're going to adjust them. I'm going to select this center line and I'm going to pull them back to the quadrant or intersection of the drilled hole. I'm going to bring this one in. I'm also going to bring this one in. And this one is going to be gripped back to the front axle. Like so. And because we're working in an imperial drawing, center lines always extend beyond their feature. Again, something that we're familiar with. So we're using 1/4 inch. And this is something that I had established with you in the previous lesson concerning the extension of the center line for the cartridge. 1/4. And continuing on, I'm just going to finish this up. Same thing goes for the top view. like that. And because there's symmetry on the top view, even though we haven't designed anything yet in terms of car shape, we know that whatever we do on one side of the blank is going to be mirrored to the other side. So we're going to take this center line and we're going to extend it to the end of the blank, and again from here extend it another 1/4 inch, like that. Now, this particular design we're working on right now is a rail car, meaning that it has the wheels totally sitting on the outside of the piece of lumber or the car body itself. So, like you're seeing here. So this is an example of a rail car. I'm going to be showing you how to do a few different designs as well as some hybrids. So it's all going to be covered very nicely to help you along. But if we were doing a rail car, this is all we would do in terms of we would just have axle holes like this. The reason the center line passes through each axle hole is to represent that these axle holes are sitting at the exact same height. So the center line communicates that to the person in the shop who's going to construct the car. In that case, it's you, which is not always the case. Usually we have designers and builders, but the language of drafting is universal. So if someone in the shop is going to build your car, your design, they would be able to look at this and say, oh, I understand the axle height for the axle hole is the same height for both drilled holes, right? So that's why you need to have your center line passing through. This doesn't represent symmetry. In this case, it represents alignment. But this is where I'm going to end today's lesson. So we are going to talk about shell cars and reveal cars next time. And any comments you have about this project, please leave them in the activity space on the hub. I'll talk to you later.